Hey everyone, and welcome to our deep dive on the C++ strings library. I know you're already out there writing code, so we're not going to bore you with the basics. Today we're going to go beyond that, hello world stuff, and we're going to unlock some of the more powerful tools that the C++ strings library offers us. We'll be using cppreference.com as our guide for this deep dive. It's kind of like the ultimate encyclopedia for all things C++. One of the first things that surprised me was how the library defines a character. It's more than just like an A or a B, right?
Yeah, it's a lot more than just a simple A or B. Think of it as anything that represents text when you line it up in a sequence. Could be a simple character,
Yeah.
a multi-byte character from Unicode, or even something from another library, like localization or regular expressions.
So it's a broader concept than I initially thought. Is this where this char-like types term comes in?
Exactly. These char-like types are really the foundation of the C++ strings library. They're essentially the building blocks of strings, and they need to meet certain criteria, like being copyable without any side effects, and having a standard structure in memory. Don't get too bogged down in the low-level details right now. Just know that they exist. What's important is that you understand this concept of character container types. These are the data structures, like std.string, that actually hold and manage our sequences of characters.
So the char-like types are like the raw materials, and the character container types are like the finished products.
Exactly. Now, to work with these char-like types effectively, the C++ strings library relies on something called character traits.
Character traits sounds like we're giving personalities to our code now.
Well, not quite. But it's a good way to think about it. Imagine you have a toolbox specifically designed for each char-like type. That's essentially what std.chartreuse is. It defines how to compare characters, copy them, move them around in memory, and even how they're handled when you read from or write to files.
Oh, so it's like having specialized tools for different types of characters.
Precisely. And the C++ strings library provides predefined std.chartreuse for all the common character types, like char, rowchart, char16, and char32. This means that as a developer, you don't have to write your own character traits, unless you're working with some really exotic custom character type.
Well, that's a relief. Sounds like the library takes care of a lot of the heavy lifting behind the scenes.
It does. But knowing about character traits gives you a better understanding of how the C++ strings library works under the hood, which is always a good thing as a software professional.
Like, so we've got these char-like types and their character traits. But how do they come together to form the actual strings that we use in our code?
That's where the std.basicString class comes in. Think of it as the workhorse of the C++ strings library. This template class handles the storage and manipulation of character sequences.
std.basicString. It sounds like the foundation of everything.
It is. And the beauty of std.basicString is its flexibility. Remember those char-like types and character traits we talked about? Well, std.basicString can handle any of them.
So I could have a string of plain char characters, or a string of wide characters, or even a string of Unicode characters, all managed by the same std.basicString class.
Exactly. And to make your life even easier, the library gives you specializations of std.basicString for the most common character types. So you've got std.string for your everyday char characters, std.storystring for wide characters, and even std.u8string for UTF-8 encoded characters, which is super helpful when working with text from all over the world.
This is starting to make a lot of sense, but why would I use these C++ strings over the C-style strings I'm used to?
Great question. Remember how I said std.basicString is a workhorse? Well, that's because it takes care of all the memory management for you. No more manually allocating and deallocating memory, which can be really error-prone and can lead to some nasty bugs.
Oh, so I can just add characters to my string, and the std.string object will just automatically adjust its size without me having to worry about anything.
You got it. And that's just the beginning. std.basicString comes with a ton of built-in methods for searching, replacing, comparing, and manipulating strings. You can concatenate strings, extract substrings, convert cases, do all sorts of cool stuff with just a few lines of code.
That sounds a lot easier than messing around with pointers and arrays like you have to do with C-style strings.
It is. And don't forget, all of this applies to the specialized string types, too. So whether you're using std.string or std.wstring, you have access to the same powerful toolbox.
So as a beginner, I can focus on actually working with the strings and let the library handle all the low-level details.
Exactly. That's the beauty of the C++ strings library. It provides a high-level interface that makes string manipulation a breeze while ensuring safety and efficiency.
This is really eye-opening.
Yeah.
I feel like I'm finally starting to see the power and flexibility this library offers.
And we've only just scratched the surface. There's a whole lot more to explore, from string views to string streams and beyond.
Well, I'm hooked. I can't wait to see what other treasures this library holds.
Yeah.
Um, Maybe we can dive into some more exciting features next time.
Yeah, let's do it.
So we talked about how std.basicstring takes care of all that memory management for us and gives us all these convenient methods. But what about when we're working with really long strings? Like, think about a huge chunk of text, like a paragraph from a book or something, and we only need to work with a small piece of it. Can we just make a copy?
Yeah, you could create a copy,
Yeah.
but that's not really efficient, especially if you're doing this over and over again.
Right. Copying all that data doesn't sound very performant.
No, not at all. And that's where string views come into play. So instead of creating a whole new copy, a string view just kind of points to the beginning and end of the substring within that original string.
So, like, if the original strings are like a big rope, the string view would be like marking off a section of the rope, but not actually cutting it.
Exactly, you got it. And because we're not making a copy, string views are super lightweight. They're just a way of referencing a portion of an existing string, which can really boost performance, especially when you're working with those large strings or doing a lot of substring operations.
Yeah, that makes sense. So does this mean string views are read-only? Can I modify the substring through a string view?
That's a good question. String views are mainly designed for read-only access. They're kind of like a window into the string, but you can't directly modify the characters through them.
Gotcha. So then what happens if I do need to change that substring? Do I have to go back and create a copy?
You can. String views can be implicitly converted to regular strings. So you could start with a string view to get that performance boost. And then if you need to modify it, you can easily convert it to a std.string and then work with that.
That's cool. So it's like I get the best of both worlds. Efficiency when I need to read,
Yeah,
and then the flexibility to modify when I need to.
exactly. The C++ strings library gives you the right tool for the job.
Speaking of the right tool, we touched on string streams a little bit earlier. I was hoping we could dive a little deeper into those. The whole idea of treating a string like a stream, that just sounds so interesting to me.
Absolutely. String streams are incredibly useful, especially when you need to work with strings kind of like you would with file input and output.
Uh-huh.
Imagine you're building a logging system for your application.
Okay, yeah, I can see how you'd be working with strings there.
Right. So instead of having to manually piece together strings to format your log messages, you can use std.basicstringstream to streamline that whole process.
Interesting. How does that work?
Well, with a string stream, you can use that familiar stream insertion operator, the on-I, to feed data into it, just like you would with std.count when you're printing to the console. Except with the string stream, all that data is going to be stored internally as a string.
Oh, wow. So I can insert numbers, strings, variables at different types, and it'll all just get formatted into a single string.
Exactly. You can mix and match data types. And the string stream handles all the conversion and formatting for you. It's a really clean and efficient way to build up complex strings.
Wow. So then once I've built up my string, like my log message or whatever, how do I get the actual string out of the string stream?
Easy peasy. You just call the .str method on the string stream object, and it gives you back the entire contents as a std.string.
Oh, that is so convenient. It's like having a mini string builder right in the library.
It is. And as you might expect, there are specialized string stream types too. So you've got std.stringstream for working with char characters, std.wstringstream for wide characters, and so on.
Wow, they really thought of everything. This C++ strings library is like a Swiss Army knife for string manipulation.
It really is. Oh, and one more thing about string streams. We've been talking about std.basicstringstream, which handles both input and output. But what if you only need to read data from a string?
I guess you wouldn't need the output part then.
Right. And so for that, you have std.basicstringstream, works just like std.basicstringstream, but only lets you read from the string. And then on the flip side, if you only need to write to a string, you can use std.basicstringstream.
So basically, they have a specialized tool for every scenario. I bet that really helps with efficiency.
Absolutely. The C++ strings library gives you fine-grained control over how you're working with strings, so you can pick the most efficient approach for every task.
Wow, this is really making me realize that the C++ strings library isn't just about the basics. It's about writing really clean, efficient, and maintainable code when you're working with text.
Absolutely. And the cool part is, the C++ strings library is designed to work seamlessly with other parts of the C++ standard library.
Now that you mention it, I'm curious. How does string manipulation fit into the bigger picture of C++ development? Like, what happens when we combine these string techniques with other powerful tools, like algorithms or regular expressions?
That is a great question. And that leads us perfectly into the final part of our deep dive. So let's take a moment, reflect on what we've learned, and then explore how we can unlock even more potential by integrating string manipulation with other parts of the C++ ecosystem.
Wow, we've covered so much in our deep dive into the C++ strings library. From the basic building blocks of characters to the power of string views and string streams. It's amazing how much this library offers, beyond just basic string handling.
Yeah, it really is amazing. It just shows how much thought and care went into designing this library. They really wanted to give C++ developers a really complete and efficient set of tools for working with text.
Yeah, definitely. And speaking of empowering developers, you mentioned earlier how the C++ strings library works well with other parts of the standard library.
Yeah.
And I'm kind of curious to explore this further. Like, what happens when we combine string manipulation with concepts from algorithms or even regular expressions?
Oh, that's when things get really interesting. It's like, you've mastered the art of crafting individual words, and now you're ready to start writing poetry.
Okay, I like that analogy. So how do algorithms elevate our string game?
Well, imagine you have a list of names, and you need to sort them alphabetically. Instead of writing your own sorting routine from scratch, you can just use the algorithms from the algorithm header.
Oh, so I could use something like std.sort to sort my list of names alphabetically.
Yeah.
In just one line of code.
Exactly. And that's just one example. You can use algorithms to search for strings within larger text, find the minimum or maximum element in a collection of strings, transform strings based on certain rules, and much more.
Wow. That opens up so many possibilities. It's like having a team of expert assistants who can do all these complex tasks on our strings super efficiently.
Exactly. And then there's the whole world of regular expressions.
Oh, yeah, regular expressions. Powerful, but sometimes a little intimidating.
They can be, but they're also super useful for things like pattern matching and data extraction. So say you're working with a huge text file filled with customer data, and you need to extract all the email addresses.
I can imagine that would be a nightmare to try and do that manually.
It would be, but with regular expressions, you can just define a pattern that matches the structure of an email address, and then use that to pull out all the email addresses from your text. The C++ standard library actually provides support for regular expressions through the Regex header.
So by combining string manipulation with regular expressions, we can do these tasks that would have taken us forever otherwise.
Exactly. And you can mix and match all these different tools and techniques to come up with really elegant and efficient solutions to all sorts of problems.
This has been awesome. I feel like I've gone from just knowing the basics about strings to seeing them as a core part of this much bigger and more powerful ecosystem.
That's really what it's all about. Mastering any programming language. It's about understanding the individual parts and then learning how to combine them to build something amazing.
I'm really excited to keep digging deeper into the C++ standard library and see what else I can build with strings. Do you have any final advice for us as we wrap up our deep dive?
Just keep exploring. Software development is always changing, and there's always something new to learn. Don't be afraid to try new things and experiment.
Well said. I think that's a great note to end on. It's been so fun uncovering all the hidden power of the C++ strings library.
I agree.
And to all our listeners out there, keep coding, keep learning, and keep pushing the boundaries. We'll see you next time.